Now let's focus on linear system word problems. So there's many different types of word problems, but most of them have like the same basic foundations on how to solve them and how to create the equations to solve them. So in our first question, we have a pair of regular earbuds that cost $56 each and a pair of wireless earbuds that cost $58 each. On Saturday, 32 pairs of earbuds were sold. The receipts totaled $1,828 before taxes. How many of each type were sold? So we need to start off by doing our let statements. So our let statements state what our variables are going to represent. So let the number of regular, and I'm not even going to bother putting earbuds, but you can if you want. So let the number of regular be X. Let the number of wireless be Y. So I'm using those two little lines to just mean same word as above. Feel free to write it all in if you wish. So now we know what X is going to represent and what Y is going to represent, and we're going to use that to create our equations. So our first equation is going to include the information about the total number of pairs sold. So 32 pairs were sold. So what that means is that the number of regular earbuds plus the number of wireless earbuds is going to be equal to 32. So we have our first equation there, X plus Y is equal to 32. Now we're going to do a second equation that takes into account the costs. So the regular ones cost $56, the wireless earbuds cost $58. And we also know the total of the receipts, $1,828. So let's do our second equation here. So first we're going to think about how to represent the cost of all of the regular earbuds sold. So we know that X represents how many regular earbuds have been sold, and they're each $56. So we're going to write 56 times X, and that'll represent all of the money from all of the regular earbuds sold. We're going to add that to 58 times Y, and that represents all of the money from all of the wireless earbuds sold. And when we add all of that money together, we are going to get $1,828. So now we have two equations, and we can use either substitution or elimination to solve for X and Y, because that's what we need to figure out, how many of each type were sold. So I'm going to use substitution, and what I'm going to do is I'm going to rearrange our first equation and get Y by itself. So we can rearrange this so that Y is equal to 32 minus X. So I'm going to put 1 into 2. Okay, always state what you're going to do. So our second equation is 56X plus 58Y. And instead of Y, I'm going to put 32 minus X. And that is equal to 1,828. So now what I need to do is I need to expand it by multiplying and collect my like terms and then isolate X. So 58 times 32 gives us 1,856. And now we want to get all of our terms with X's together. So 56X minus 58X gives us negative 2X. And we're going to move that 1,856 to the other side and subtract it. So we end up with negative 2X is equal to negative 28. Okay, we want to get X by itself, so we're going to divide negative 28 by negative 2, and X is going to be equal to 14. Okay, then now that we have that, we can substitute it in to the other equation. So we did 1 into 2, so that means we need to do X is equal to 14 into equation 1. And I'm going to do it into the second version of equation 1 there because it already has y isolated for me. And 32 minus 14 gives us 18. So now we have x and we have y, and we can answer our question about how many of each type are sold. So therefore, 14 regular earbuds and 18 wireless. Oops. Okay, so 14 regular earbuds and 18 wireless earbuds were sold. Make sure that you always have a summary sentence or that you are paraphrasing your answer and that you have proper units if there are any units. In this case, it was just numbers of earbuds. Okay, let's go to our next question. So our next word problem, we have one type of snack mix that contains 30% nuts by mass and a second type of snack mix that contains 20% nuts. How many of each type is needed to make a 500-gram mixture that will have 24% nuts by mass? So we're going to start out like we did with the other question. We're going to write our let statements. So we're going to say let the amount of 30% nuts, and we mean the snack mixture with 30% nuts, be x, and then let the amount of the snack mixture with 20% nuts be y. Okay, now that we've written our let statements, we're going to use that to help us create our equations. So our first equation is going to take into account the amount. So we know that we need a 500-gram mixture in the end, and so we need to know how much of each of these other snack mixtures to use. So we're going to do x plus y is equal to 500, right? So some amount of the mixture that is 30% nuts, some amount of the mixture that is 20% nuts, add them together and get 500 grams. Now, our second equation is going to take into account the percentages of nuts in each of these snack mixes. And there's different ways to do to kind of represent this. I like to represent my percents as a decimal. You do not need to in this case, however. So our first amount that we want to represent is the amount that is represented by the snack mix with 30% nuts. So we are going to call this 0.30x, and that 0.30 is coming from 30% as a decimal. And then we're going to add some amount of the snack mix that is 20% nuts. And altogether, we are going to get 500 grams of the snack mixture that is 24% nuts. Okay, so let's go over this last one again. We have an amount of the 30% nut mixture plus an amount of the 20% nut mixture. That is going to give us 500 grams of the 24% nut mixture. Now that we have our two equations, I'm going to use substitution. You are welcome to use elimination if you wish to solve for x and for y. So I'm going to take the first equation and I'm going to isolate y. So I have y is equal to 500 minus x. And now I'm going to put my first equation into my second equation. So 1 into 2. So 0.30x plus 0.20. And now instead of y, here we're going to put that 500 minus x. And that is going to be equal to 0.24 times 500. And that gives us 120. Okay, so the 120 comes from actually doing the multiplication right above it. So now we're going to expand, simplify, and isolate for x. So 0.20 times 500 gives us 100. And we end up with 100 minus 0.20x is equal to 120. And we want to get all the terms with x together. So 0.30x minus 0.20x gives us 0.10 or 0.1x. And we are going to bring that 100 to the other side. So we end up with 0.10x is equal to 20. And we want to divide 20 by 0.10 to get x by itself. And when we do that, we get x is equal to 200. So now we have x, and we're going to then substitute this into our first equation to get y. So x is equal to 200 into our first one. I am going to use the rearranged version or the modified version of the first equation because y is already isolated. So y is equal to 500 minus x, y is equal to 500 minus 200, and y is equal to 300. So we can just do a quick visual. 200 plus 300, that gives us 500. Okay, that makes some sense. So now we know that we need 200 grams of the snack mixture that is 30% nuts, and we need 300 grams of the snack mixture that is 20% nuts to then create this mixture of 500 grams that is 24% nuts. So let's just do a quick summary statement of that. So therefore, 200 grams of the 30% mixture and 300 grams of the 20% mixture are needed. Okay, last word problem. A trip involves traveling by bus and then by car. The speed of the bus is 80 kilometers per hour and the car 100 kilometers per hour. The total time for the trip was 6 hours and the total distance 520 kilometers. How much time was spent on the bus and in the car? So what we're going to do here is we need to first remember our speed equation. So speed is equal to distance divided by time. And we can always rearrange that equation to solve for either time or to solve for distance. Now let's look more closely at the information that we are given in the question. So we are given information on speed, and we're given information on time and distance. So we're given total time, we're given total distance. But what we're actually asked to find here is how much time was spent on the bus and in the car. So what I'm going to do is I am going to tailor my let statements to time. So instead of to distance, to time, because we are specifically being asked to find time. So our first let statement is going to be let the time on the bus be represented by x. Okay, so let the time on the bus be x, and then let the time in the car be y. Okay, so both of those are built on time. Okay, now we're going to make two equations based on the information we have. So our first one is going to be on time specifically. So x plus y is equal to 6. because we know the total time for the trip was 6 hours, and we've decided that X is going to represent the time on the bus and Y the time in the car. So I'm going to just write the word time here to show what we are using. And then our second one, we're actually going to use distance. So we are going to go over to our speed equation in the corner, and we are going to rearrange for distance. And I'm just going to use letters here. But if we arrange for distance, distance is going to be equal to speed times time. Now, in our question, we are given the speed, and we already have figured out that we have X and Y to represent time. And we have the total distance, right? We're given the total distance is 520 kilometers. So we are going to use 80X to represent the distance that the bus has traveled, because the bus is going 80 kilometers per hour, which is our speed, and we're multiplying by X, which is our time, and we're going to add it to 100Y. So the speed of our car times the time it takes our car to travel. And our total here is 520. So this, we are doing distance. Now, the rest of the question, that was the hard part, setting up those equations. The rest of the question we are going to solve as we did the others. And I'm just going to rearrange question 1 again so that we have it as Y is equal to 6 minus X. Again, you can also solve this using elimination. So I am going to do equation 1 into equation 2. So we have 80X plus 100 times 6 minus X is equal to 520. Okay, just remember the 6 minus X is coming from that rearrangement of the first equation. So now we are going to expand, simplify, and isolate for X. So we have 80 times X plus 600 minus 100X is equal to 520. 80X minus 100X gives us negative 20X. And then we end up with 520 minus 600 on the right-hand side. So negative 20X is going to be equal to negative 80. And to get X by itself, we're going to divide negative 80 by negative 20. And we end up with X is equal to 4. So now we have how long the time is for the bus. And we're going to take that X is equal to 4, and we're going to put it into our first equation. So Y is equal to 6 minus X, or 6 minus 4. Y is going to be equal to 2. So now we know how long was spent on the bus, how long was spent in the car. Let's write a summary sentence. So therefore, 4 hours was spent on the bus, and 2 hours was spent in the car.